Today let's talk about a fraction as a percent. Here's some vehicles. We have 3 cars and 2 trucks. Take a minute and create 2 ratios that accurately describe this picture. One ratio shown here is how many cars there are out of the whole, 3 to 5. Another ratio would be part of the whole to the other part of the whole. In this case, cars to trucks, 3 to 2. Or we could flip those parts around and say trucks to cars, 2 to 3. We could also say the other part to the whole, trucks to the total number of vehicles, 2 to 5. So Sam looks at this and says 50% of these vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. His statement once again is that 50% of these vehicles are cars. If Sam is dealing with cars out of the whole, right, 50% of the vehicles are cars, part to whole, then we can look at the total, 5 vehicles, and say that 3 of them are cars. The fractional value is 3/5. But if we want to find the percent, then we know that we need to have the whole equal 100. And so I know that 5 times 20 is 100. So if I multiply both the numerator and denominator by 100, I will have a whole of 100, which will make it nice and easy for me to see the percent. And because 3 times 20 is 60, and 5 times 20 is 100, we have 60 hundredths, which we also know is equal to 60%, because with this fraction, 100 makes the whole. Another way we could test Sam's quote is by making a diagram. Here I have 5 vehicles represented by 5 blocks. I'll shade 3 of these pink to represent cars and 2 purple to represent the trucks. In order to find the percent, I need to make the total the same value as 100 because percents are always dealing with 100 as the whole. So all 5 of these vehicles need to be equal to 100. And from here I can now label the rest of the blocks, knowing that there are 5 of them and it takes 5 to get to 100. Each block is worth 20, 20, 40, 60, 80, 100%. Because I now have it nicely labeled, I can also see that where my cars are, the 3 pink, equals 60% of the whole. So yes, 60% of the vehicles are cars, and Sam was incorrect, not 50%. By the way, what would 50% of the total vehicles be? Again, percents are related to fractions by being out of 100. So 50% is the same thing as saying 50 out of 100. And we know that we can simplify 50 over 100 to 1/2 if we divide both by 50. So 1/2 of the vehicles would be 50%. Is that the case with our 3 cars and 2 trucks? Again, no, Sam was not correct. 50% of the vehicles are not cars. How is the fraction of cars, 3 out of 5, related to the percent, 60%? Well, 3 out of 5 vehicles is equal to 60%, which I can write as 60 out of 100. And because I know that 3/5 can equal 60 100ths if I multiply the top and bottom by 20, then I know that both of these fractions are equivalent. So 3/5 is equal to 60%. Let's prove this, though, with a model. Here's our same model as before. 3 cars, 2 trucks, equaling 100%, all 5 together. Now, if I count off these vehicles, 1, 2, 3, 4, 5, then I can see where 60% is and that it matches up with 3 vehicles out of the 5. So yes, again, 3/5 of these vehicles is the same as saying 60% of these vehicles. What other fractions or decimals represent 60%? Well, now we know that 3/5 equals 60%. So if we double 3/5, we'll get 6/10. And because that's equivalent to 3/5, it's also equivalent to 60%. And because 9/15 is also equivalent to 3/5, right? 3/5 tripled will give us 9/15. Then that means 9/15 is also equivalent or equal to 60% as well. And 12/20ths is 4 times as much, and so that's equivalent to 3/5, which means 12/20ths is the same as 60%, and we could go on and on. So a survey was given that was asking its participants whether or not they were happy with their jobs. 300 of these participants were unhappy, while 700 were happy with their jobs. What fraction of the whole were happy? 300 participants were unhappy, 7 were happy. What fraction of the whole were happy? Well, what is the whole? Is the 300 people, is that the whole amount surveyed? Or is the 700 the whole amount surveyed? Neither. Rather, the whole would be all people surveyed, both the 300 and the 700, making a total of 1,000. And if the question is, what fraction of the whole were happy, and we know that the whole was 1,000, and that the happy people total was 700, then the fraction is 700 out of 1,000. There's our fraction. So then, what percent are happy? Okay, our fraction is 700 out of 1,000 people who are happy. How do we turn this into a percent? Well, we know that a percent has to be out of 100. So how can we make the whole here 100? Oh, 1,000 divided by 10 is 100. So, if we divide both the numerator and denominator by 10, then we will have a whole of 100, and it will tell us our percent. 700 out of 1,000 is equivalent to 70 out of 100, and 70 out of 100 is a percent. 70%. 70 out of 100. And let's not forget the question, what is the percent of people happy? 70% of the participants are happy with their jobs. So now you tell me, what is the fraction of the people who are unhappy with their jobs? Remember our data, 300 of the people were unhappy, while 700 were happy. So, what fraction of the people are unhappy with their jobs? We know that 300 people are unhappy, and the total amount of people surveyed were 1,000, so our fraction is 300 people out of 1,000. 300 out of 1,000. So then, what percent is unhappy with their jobs? Our data says 300 out of 1,000. But wait, percentages need to be out of 100. So what should we do? Yes, we can divide 1,000 by 10. And of course, we have to always deal in equivalency, so we must divide the numerator by 10 as well, leaving us with 30 out of 100, which tells us a percent because it's out of 100. 30% of the people surveyed are unhappy with their jobs. Can you create a model to justify what we just found? So here's a model of 10 boxes. I made 10 so that I could label each one 100, going all the way to 1,000, because remember, 1,000 people were surveyed. Also, if I made this 10 boxes, that helps me in my percentages, because I know the total needs to be 100%. So here's 10, 20, 30, all the way to 100%. If we look at the total people unhappy, 300, then we can see that yes, that is equivalent with 30% of the whole. And if we look at 700 people that were happy, we can see that it equates with 70% of the whole. Tell me this, why was it helpful for us to write our fractions with a denominator of 100? How would we represent 70% as a decimal? 70% as a decimal would be 70 hundredths, right? 70% is the same as saying 70 out of 100 or 70 hundredths, and as a number, 70 hundredths is written as 0.7 or 0.70. 70 hundredths is still written this way. Why without the 0? Because there is still a 7 in the tenths place and a 0 in the hundredths place, making this the same as 70 hundredths. Renita, she took a test, and she claims that a score of 80% on her test means that she answered 4 out of every 5 of the problems correct. She drew a picture to support this claim. Here's the model that Renita drew. to support her claim that 80% means that she answered 4 out of 5 correct. Is Renita correct? Why or why not? Take a look at this model. 80% is what fraction of the whole quantity? If Maria completed 3/4 of her workday, what percent of her workday does she have left? Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he's finished? Here's 1/8. What is this as a decimal and as a percent? Here is 35 hundredths. What is this as a fraction and as a percent? Here is 84 and 5/10%. What is this as a decimal and what is it as a fraction? Here is 325 thousandths. What would this be written as a fraction and as a percent? And lastly, here is 2 25ths. What would this look like written as a decimal and a percent? What have we learned today? For one thing, we've seen that fractions, decimals, and percentages are all related. In fact, to change a fraction to a percentage, you can scale up or scale down so that 100 is in the denominator. For example, to find out what 9/20ths would be as a percent, we would simply need to make the denominator 100 by scaling this up. Because we know that 5 20s makes 100, then we would simply scale up both the numerator and denominator by 5, giving us 45 hundredths, which tells us that it is equivalent to 45%. We have also seen that there may be times when the best thing to do is to take a fraction and turn it into a decimal first to find out its percent. Here's what I mean. Take the fraction 5/8. What is that as a percent? This fraction is difficult to turn the denominator into 100. 8 times what is 100? So rather, we can take the fraction and turn it into a decimal by dividing the numerator by the denominator, 5 divided by 8, which we found here to be 625 thousandths, which we know is equivalent to 62.5%. Remember, percents are always out of 100. And lastly, we saw again that models like tape diagrams and number lines can also show relationships. Remember this model? We took a whole and divided it into 5 vehicles. We also knew that the whole amount of vehicles would be equal to 100, and we're able to divide up the parts into percentages as well. And this helped because when we wanted to know the percent of a certain amount of vehicles, we could always look at the model to see what was related. In this case, if we wanted to know what 4 of the vehicles out of the 5 total would be as a percent, we could look and see that 4 out of 5 is related to 80% of the whole.